nothing but a table. So now you need to start practicing what you're looking for. What is the most important thing? What are they asking you to find at the end of the problem? Find that in the words of the problem. What do they want at the end of the problem?
Determine how many cakes and pies he should produce.
How many cakes and how many pies should be produced? Cakes, pies. Not on the rows. Don't put them over here on the rows, because then your matrix is going to look like you're rotated at 90 degrees, and it's not going to look like the matrix that you want to put into the calculator. And if that's not good enough for you, and some of you might want to start here. If you don't recognize this as being, if you can't figure out this, then start with the totals. Go back into the problem. Where did they mention totals?
Each cake is 3 hours and $15.
3 hours is a time factor. $15 is a money factor. Those don't seem like totals to me. He won't work more than 15 hours per day. That's the hours he's going to work. And he doesn't want to spend more than $93 on supplies. Okay, so those are the characteristics of hours and supplies. But those 15 hours are split up over what? Those total of 15 hours are split up in making what? Cakes and pies. If you can't figure out what the column headers are, then go to the totals, because those are always going to tell you what the rows indicate. And then the columns are the only thing left for you to be able to fill in. Now you're going to put in all the numbers. What's it tell you about cakes? 3 hours to produce each cake. That better go where cakes and hours intersect. And what else?
$15.
Costs $15. So that better go where costs and cakes intersect. Each pie, 1.5 hours. And each pie costs $12 to make. I don't see any variables in there, but if I'm going to create a system, I gotta have variables, and the column headers are always where the variables will go. So in this particular case, everything in this column is going to be represented with an X, everything in this column is going to be represented with a Y. 3X plus 1.5Y equals 15. 15X plus 12Y equals 93. There's my system. They may ask you to write the system, and that may be the only thing they ask you to do. They may ask you for the system, and then they may ask you for what the augmented matrix is. If they want the augmented matrix, don't you already have that when you filled in the table? This is why we like the table approach. So what are the coefficients? What are the number values on the first row? 3, 1.5, and 15. What are the number values on the bottom row? 15, 12,
and 93.
and 93. There's your augmented matrix. There's your system. Could you solve that system by hand if you wanted to? Is this going to be a little bit more challenging to do? Substitution isn't quite such a good, attractive topic in the problem, is it? So maybe trying to solve it by hand would take longer than solving it with the augmented matrix. You're not going to be required to draw in that vertical line for the augmented matrix, but we do know that that RREF that we put out in front tells us what we're doing to that augmented matrix. Because we are also going to have matrix operations to do. So should we be able to solve this one? Okay, step one. Muscle memory time. What do you do first?
Second. Matrix.
Second, x to the negative 1 to get to the matrix.
And then edit.
Edit. Do I need to start a new matrix, or can I cannibalize or reuse an existing one?
Maybe reuse.
Same size, right? As long as it's the same size, I might as well keep using it, unless you want to keep that previous problem, in which case now you got to create a new one. Then you got to remember what you put where, and that ain't going to happen too often. Okay? We still want 2 rows and 3 columns, but the ingredients we want to work on are a little bit different, aren't they? So the ingredients are 3, 1.5, 15, 15, 12, 93. Enter the matrix menu. Declare your intentions to edit. Put in the information. Get out of the matrix menu, because you're stuck in the editing phase right there. Go back into the matrix menu.
Put a math.
Go into the middle column for math, and go find your reduced row echelon form. If you don't have a calculator that you can scroll up and pull it up on. It'd be nice if they all did that, but the 83s are older, but they still get the same effect in the problem. If I don't enter anything, the calculator is going to get real upset because I told it to go somewhere but didn't tell it where to go. So I neglected to tell it where the information was it was supposed to apply that command to. So back into the matrix menu again. See, we use that matrix access 3 different times. And we use something out of each one of the columns each time as well. Okay, so we're pulling up matrix A. Whether we close the grouping symbol or whether we don't close the grouping symbol, it doesn't make a difference. So how do we interpret this reduced row echelon format? See why they call it reduced row echelon format now? We reduce the number of unknown quantities on the rows and in the echelons, which is French for columns. Okay? So how do we interpret this?
X is equal to 3.
That x is equal to 3 and y equals 4. And is it kind of important we know what x and y were? But when we go back and look at the table, didn't we declare what x and y were? So I just didn't necessarily have to write a sentence about that. I could have included that in the column header. So in order to get the best effect out of there, this chef is going to produce 3 cakes a day and 4 pies. And that's going to be called a day for him. Now, what's he selling them for? That's a different story. We're not worried about that right now. So I took away the hints for you, but I gave you the columns to be able to create, and I took it almost all away.